Hello, hi. This is the final lecture on Coleochaete algae. We have already discussed the general account and asexual reproduction in Coleochaete. So, continuing to the sexual reproduction in Coleochaete, we know that there are two kinds of species in Coleochaete algae. One displaying heterotrichous condition where there are prostrate and erect branches, and the other displaying discoid thallus where only prostrate type of habit will be seen. In Coleochaete algae, in the case of heterotrichous species, we can see that it may be homothallic. It will be displaying homothallic condition. Okay, what is homothallic condition? The male and female reproductive organs will be born on the same thallus. Okay, this is one single thallus, and on its different branches you can see female reproductive structure called oogonia or carpogonium and male reproductive structure called antheridium. Okay, this is the homothallic condition which is observed in Coleochaete pulvinata. In the case of discoid thallus like Coleochaete scutata, the male and female reproductive structure will be born on different thalli. Okay. Then one thing about the location of this male and female reproductive organ. In the heterotrichous species, the male and female reproductive structures will be seen in clusters, not in single condition, but in clusters, and that too on the top of apical filaments. On the top of erect filaments. At the tip of the erect filaments you can see antheridia and oogonia in clusters. And in the case of discoid thallus like scutata, the antheridia and oogonia will be present somewhere in the interior of the thallus, not at too near periphery, not at the center, but somewhere between the periphery and the central cells. So that's about the location of these male and female reproductive structure. Now going into the process. So when is the time for sexual reproduction? The time is almost near the winter season, when the conditions are unfavorable, when there is no much light, no much water, no much nutrients, etc. So during this condition, this kind of sexual reproduction will be happening. Asexual reproduction, we have already discussed that it will be happening during the favorable circumstances like spring and summer season. Now the process. When about to begin sexual reproduction, the entire protoplasm of the antheridia will be converting itself into a uninucleate and biflagellate antherozoid. Okay, so that's about antherozoid. And at the oogonium is actually a flask-shaped structure. The top, at the tip of the oogonium will be a slender, elongated, neck-shaped structure called a trichogyne. Okay, and at the base of the oogonium will be a swollen type, and within that one of the nuclei, only one nuclei will be there of that particular cell. That nuclei will be converting itself into egg. During maturity, during the time of sexual reproduction, this trichogyne will burst open. You can see that its head is removed. Now the antherozoid, which is released into the water, will be swimming and coming and entering into the entering through the trichogyne to the oogonium. But you know that there will be maybe hundreds and thousands of antherozoids will be released, but only one will be entering through the first one which is entering will be fusing with the egg cell. So after entering, the antherozoid will be releasing its male nuclei to the interior of oogonium, and both will be present. Male and female nuclei will be present in the oogonium for some time. They will not be fusing suddenly. They'll wait for some time, because you can see that the size of male and female nuclei is different. Male nuclei is little smaller than the female nuclei, so they will take some time till male and female nuclei are almost similar in size. After that, it will be fusing. So a diploid zygote will be formed. Once the zygote enlarges its size, it is called oospore. Okay. So for becoming oospore, the surrounding cells of the zygote, the cells of the oogonium which are surrounding the zygote, will be dividing, and it will be forming a parenchymatous sheath. You can see a green color sheath. Okay, it will be forming a parenchymatous sheath around the zygote. Okay, so at this stage we are calling it a spermocarp. Okay, this is a spermocarp. Okay, and initially it will be a reddish brown in color. You can see that a reddish brown in color structure. Okay, so during the time of division, what will happen is that this spermocarp will start dividing. Okay, this spermocarp will start dividing. First it will do a transverse division. then the successive division will be at right angle to the first division. After some time, after the division is complete, there will be around 8 to 32 such cells within the spermocarp. Okay. Now during the maturity, the 8 to 32 cells will be converting itself, will be transforming or metamorphosing itself into 8 to 32 zoospores, and the spermocarp will be breaking open, and will be forming zoospore. Before that, let me add one more point. After the spermocarp is formed, okay, before its germination, what will happen is that like after the spermocarp is completely mature, before breaking it open, it will be staying dormant in the reddish brown condition in the water for the period of unfavorable situation. Once the winter season is over, this thing will be happening like this. It will be bursting out and releasing the zoospores. Okay, so the uninucleate biflagellate zoospore will be having a chloroplast, okay, a cup-shaped chloroplast, and it will be having a uninucleate condition, but it will not be having an ispod. Okay, but it will not be having an ispod. So this is the feature of zoospore. And if you just compare the anthrozoid and zoospore, what is the difference? Both are almost looking same, but anthrozoid is not having any chloroplast, right? So this is the difference between zoospore and anthrozoid. And zoospore will be having a cup-shaped chloroplast, and it will be having one or two maximum like one or two pyrenoids or starch storing bodies will also be there. This zoospore will be swimming for some time, and then it will be settling on some suitable substratum, and then it will be germinating and forming a new thalli. If it was a species of discoid thallus, it will be forming a diploid thalli. It will form a discoid thalli. And if it is the oospore which was made from the Heterotrichus species, it will be forming a Heterotrichus thalli. So this is one pencil drawing. This is an easy to draw figure. Okay, you can just draw it with pencil simply. So this is about the reproduction, sexual reproduction in Coleochaete thalli. And one thing you can observe is that the entire phase, you can see, once the anthrozoid is released, from here till the fusion of male and female nuclei, till the oospore is formed, the entire structures were haploid. When the male and female nuclei fused, then only a diploid zygote is formed. So that is one thing you have to remember. So the coleochaete displays haplontic life cycle. So that is one thing. Now here is the notes. You can pause the video and write the notes if you want. Everything what I have explained till now, I have beautifully written in a very simple and crisp form in these slides. So that is one thing. And one thing I have forgot to mention, that is, in the case of discoid thallus species like Coleochaete scutata, in its female thalli, trichogain will be absent. Okay, only in the Heterotrichus species we can see trichogain at the top structure of oogonia. In the discoid thallus, trichogain is absent. Instead of that, there will be a small projection called papillae. Okay, there will be a small projection called papillae for the entry of this particular anthrozoid. That you can remember. I have mentioned that somewhere in the note. Yeah, here. Coleochaete scutata, the trichogain is absent and neck is represented by a short papillae. Okay, fine. So then fertilization, what will happen during fertilization? Then what is the post-fertilization change? Then about the germination of the zygote. So have you observed one thing? For the answer, I have displayed the entire answer to the examiner by writing several subheadings: structure and development of Antheridia, structure and development of oogonia, what will happen during fertilization, what will happen after fertilization. That means you have to write about the spermocarp formation and all. Then germination of the zygote, what will happen? Spermocarp will be shed in water and then it will be degenerating the basal cells, and it will be remaining dormant, and during favorable condition it will be turning green. Okay, during favorable conditions the spermocarp turns green. Initially it was reddish brown condition, then it will be turning green during the time of germination. Then it will be dispersing the 8 to 32 daughter cells which got converted into biflagellated zoospores. So this is the structure that is given in the textbook and in the online sources. but it looks complicated. That's why you can refer the pencil drawing diagram which I have given in this slide before. So then one thing about, if there is a single question about a short note about life cycle of Coleochaete, you can write it in this way with the help of a diagram. You have to draw this diagram and you can write it this way. Okay, the life cycle of Coleochaete is haplontic type. The thallus is haploid, and thallus represents the gametophytic generation. The thallus produces antheridia and oogonia on the erect branches if it is a heterozygous habit. Then antherozoids and oogonia take part in fertilization and fuse to form a diploid zygote. After the fertilization, that is post-fertilization, a diploid spermocarp is formed, which represents the diploid sporophytic generation. So only this stage, the spermocarp stage, actually spermocarp is the sporophyte here because it is the one who is going to produce the zoospores. So spermocarp is the sporophyte here, and it is the only diploid condition. So we can say that the life cycle of Coleochaete is haplontic type. Okay, a sexual cycle means what? Coleochaete thalli will be producing zoospore. One of the cell will be converting itself into zoosporangium, and that will be releasing a zoospore, and you can see that it will be zoospore will be germinating into Coleochaete thalli. And in the case of sexual cycle, you can see that there is a male filament, female filament, there are reproductive structures, then fusion, spermocarp. In spermocarp, meiosis happens. That we told that there is 8 to 32 cells will be formed. That is through reduction, division and meiosis, and through the formation happening of meiosis, zoospores will be released. Zoospore will be germinating to Coleochaete. So this figure you can easily draw even in the case of range of life cycles. Okay, in if that is being asked as a short note question or maybe a 20-mark question, they can ask like this: ranges of thallus structure or ranges of life cycle in algae. So if you want to write about haplontic life cycle, you can write this flowchart diagram. Okay, you need not draw the figure. If it is a solved question about ranges of life cycle in algae, because you need to mention many life cycles. You can mention for haplontic, you can mention about bollworms, Edogonium, etc., and even the Coleochaete life cycle you can mention as part of the haplontic life cycle. So this is all about Coleochaete. Hope you have enjoyed the video. If you have any doubts, you can write that in the comment section. Okay, that's about that thing. Thank you.